Welcome to our new lecture video on work, energy and power. So, we are familiar with work, energy and power. In our daily life, we use this word work. Like I can say that I'm going to work, I have to work out a problem, etc. etc. So, from the above example or from the example I said, we can say that it is the clear that work is the word work is used for general meaning and not for a particular meaning. In physics, the word work has a particular meaning. Same is the case for energy and power. In this lecture video, we will explain the exact meaning of work, power and energy according to the physics. So, first of all, we'll discuss work. In physics, work is done when a force acts on an object and the object moves along the direction of the force. So, in physics, the work is done when a force act on an object. Suppose this is our object O. A force act on an object. An object moves along the direction of the force. An object moves along the direction of the force. Suppose this is the displacement OP. Then we can say that this force has some works done for this body. This is the meaning of work in our physics. So what is the definition of work? The definition says that if force is applied on an object, if force is applied on an object, if there is a displacement of the object, so there is a displacement OB. So there is a displacement of the object. That the product of the force and the component of displacement along the direction of the force is applied is called work. So it says that the work is equals to the product of force and component of displacement along the direction of force. And the component of displacement along the direction of the force is known as work. So here S means component of displacement, component of displacement along the direction of force, along the direction of force. So this is the important factor, the component of displacement. We will discuss this in our further videos. So now coming to the point that we can obtain work by multiply force with the displacement, or the product of force and displacement is known as work. Here we know force is a vector quantity and displacement is also a vector quantity. From there we can say that work is a scalar quantity. Work is a scalar quantity. Is a scalar. So we know when two vector quantity is multiplied, when the product of two vector quantity, if it gives a scalar quantity, then we know this is a dot product. So for work we can say that W equals to F dot S, or you can say that Fs cos of theta. We'll prove this equation in our next part, but we have to remember this. The formula of work is Fs cos theta, and this S cos theta means this S cos theta is known as component of displacement along the direction of force. Component of displacement along the direction of force. So this is the whole scenario. There are two kinds of work. One is work is divided by two. One is positive work. Another one is negative work. One is positive work, another one is negative work. So what is positive work? If the force has a component in the same direction as the displacement of the object, So I applied force and the force, the displacement is happen the direction of the force. Then we know this kind of force is known as positive work. Let us take an example. If a body is allowed to fall from a certain height, the body being attracted by the force of gravity. So if I allowed a body to free fall from a height h, then here a gravitational force is applied. Gravitational force is applied on that body. On that body. Hence, the body moves in the direction of the force. So the body goes downwards, and the gravitational force acts downwards. So this kind of work is known as positive work. And what is negative work? Negative work says that if a force component points the direction opposite to the displacement. So I applied force and the displacement is opposite to my force. This is known as negative work. So let us take an example of negative work. We can say that when a brake is applied on a car, when a brake is applied on a car, on a car, in this case, force due to brakes acts against the motion of the car. So our brake is acts against the motion of the car, acts against the motion of the car. Hence, force and displacement are against each other. Force and displacement are against each other. So this kind of force is known as this kind of work is known as negative work. So we know what is work, what is positive work, what is negative work, and we get the formula of W of Fs cos theta. Now let us prove the formula we just derived. Suppose here is a body, this is a body, and I act a force on that body F at that direction. But the displacement is happened of that body in that direction. So now after this is O point, this is A point, and this is B point. I act force on OA position, but our displacement is happen in OB position. And this F and S create an angle of theta. Along these two vectors. Then after some time, it stops at B position. Now draw a perpendicular from B to OA. So BD is perpendicular to OA. So we know what is work. Work is the product of force. And the displacement, the component of displacement along the direction of the force. So this is our displacement. So what is the component of displacement? This part is known as component of displacement, OD. This part is known as component of displacement of S. So OD is the component of displacement. So from there we can say that, so what is the component of displacement of S? So of S, for S we can say that here the component of displacement is S cos theta. S cos of theta. The component of horizontal axis for this vector S is S cos theta. So we will add S cos theta here. And we know displacement and force are vector parameters. From that we can write F dot S. So hence we prove that our mathematical equation for what? Mathematical equations for what? So this is the mathematical equations. Here we can see that here is an angle of theta. So due to this angle of theta, there are some cases for positive, negative, and non-work cases. So for some cases of theta, we'll get positive work, negative work, or zero work. So here, first of all, if theta equals to 0, if theta equals to 0 degree, then our W equals to Fs, because we know cos 0 degree means 1. Cos 0 degree is 1. So when theta is 0 degree, then the maximum work has been done. Maximum work is done. And when theta equals to 90 degree, then our cos 90 degree means 0. Then our W is 0. So when two vectors are perpendicular to each other, means force and displacement are perpendicular to each other, at that case our theta, our work is 0. That means no work or zero work. It is known as zero work has been done. And when theta equals to 180 degree, then our W is minus of Fs, because we know cos 180 degree means minus of 1. So that is minimum work. Minimum work. So this is known as minimum work. Oh, sorry, not maximum work. This is known as positive maximum positive work. Positive work. This is known as negative work. Positive work and negative work. Negative work. So what is the range of positive work and negative work? We find out that when our theta is between 0 degree to 90 degree. When our theta is greater than or equals to 0 degree and less than 90 degree, then our work is positive. And when our theta is greater than 90 degree and less than or equals to 180 degree, then this is our negative work. So this is the whole formula, the what is the cases for theta in the work we just discussed. Now last part of our video is we do a comparison between positive and negative work. So let's just discuss about the positive versus negative work. So what is positive work? If there is a displacement s, these all are vector parameters. If there is a displacement s on an object due to the force F applied on it, if F and S are in the same direction, or if there is a positive component of F along the displacement, then work done is positive work and work is done by force. So when our force and the displacement of, or the component of displacement is along with the force or the direction of the force, then this is known as positive work. We can say that positive work, the work is done by force. Also for positive work we can say that work is done by force. And for negative work, if there is the applied displacement s, if there is applied displacement s opposite to the applied force F applied on it, on, or if there is a negative component of F along the displacement, then work done is negative work or work is done against force. So actually this is the similar. When our displacement and force are opposite to each other, then this is known as negative work, or our component of displacement is opposite the direction of the force, then it is known as negative work. Or for negative work we can say that the work is done against force. The work is done against force. So work done by force is positive, work done against the force is negative. Kinetic energy increases due to the work done by the force. This is important point. When our positive work happened, the kinetic energy increases, and when negative work when negative work happen, our potential energy increases. In the same manner, vice versa, potential energy decreases due to the work done by the force. And for negative work, kinetic energy decreases for work done against the force. Another thing is, when positive works happen, objects accelerate due to the positive work. And for negative work, objects declare. Here, positive work objects accelerate and negative work objects declare due to negative work. And we know we discussed this thing in for negative work, our theta is greater than 0 degree and less than 90 degree. And for our negative work, the theta is greater than 90 degree but less than equals to 180 degree. That's all for today's video. I hope you understand about work. Please do subscribe to our channel and like this video. Thank you.